So now that you've practiced converting from standard form to slope-intercept form, we're going to do a second quick little video. It's just converting any formula from one form to another. So you should be on the last page of your handout. We're going to be going over these 4 examples. So let's get started. So converting formulas. So in general, just like we converted the linear equation, we're also going to convert formulas like this one. Volume equals length, width, and height. F equals ma. That's a physics formula. V equals d over t, which is velocity equals distance over time. Circumference equals 2 pi times radius. Area is equal to pi r squared. Some of these formulas you'll see in physics or in geometry in the following years. But we should be able to manipulate these equations. So we're going to start off with these 4. So here's number 1. So we're going to be solving for W. So instead of having V equals, our goal is to have W equals. So meaning, we need to take anything that's on the right side of the equation, that's not W, and eliminate it and move it to the left side of the equation. So what this is pretty much telling me is V is equal to length times width times height. So the length and the height are both multiplying the width. So the opposite of multiplying is dividing them to cancel them. So I'm going to put division signs on both sides. And because I want to get rid of the L and the H, I am going to divide by L and H on both sides, because that will eliminate the L on the left side, on the right side, and it will also eliminate the H. And now all I have left is the W on the right side. The left side, I have this weird fraction, and that's fine. You're not going to simplify it because you can't simplify it. There are 3 different letters. So we're just left with V over LH equals W. And I'm just going to add one more step to this. I'm just going to flip it around. I'm going to have W. I don't want it highlighter. I want a pen. So I'm going to have W equals volume divided by length times height. If the L and the H are backwards, it's no big deal. So that's how I solve an equation from one form to another if I want to solve for W. All right, let's go on to the next example. All right, so for number 2, we have the force equals mass times acceleration. So this time I want to solve for the letter M. So in order for M to be all by itself, I need to eliminate the A that's next to it, or the A that's multiplying to it. So the opposite of multiplication is division. So I'm going to divide both sides again. Since I want the M alone, I'm going to cancel the A by dividing both sides by A. And just like in the previous problems, the A's cancel on the right side, and it frees up my M. So F over A, you don't simplify it. I'm just going to rewrite it backwards now. M equals force divided by, just clean that up, force divided by acceleration. So that's how I solve for a different variable in this example. Let's go ahead and move on to 3 and 4. So here we want to solve for distance. In this case, we have volume equals distance over time. So in this case, our distance is on the same side with the time. So I want to eliminate time in order for distance to end up by itself. So I have distance divided by time. So time is dividing. So what is the opposite of division? If you said multiplication, you are correct. So I am going to go ahead and multiply both sides by t. So I'm going to put a times t on the right side. And what I do to the right, I do to the left side. So I'm going to go ahead and multiply both sides by t, which allows me to eliminate the t's on the right side. And I'm left with t times v on the left side. In this case, it doesn't matter if the t or v go first. You'll have the same answer or same expression. So tv equals distance. And I'm just going to flip it over. Distance equals time times velocity. Now you can write it like that, or you can just write it like this. If you prefer, you can also write it like that. Any of these are fine. Let's go ahead and move on to the last one. This time we're going to solve for radius. So area equals pi radius squared, so we want the r to be by itself. In this case, we need to eliminate the pi and the little power of 2 on the radius. Now, I can't divide by just a square, so I can't get rid of it just yet. So I'm going to start off by eliminating just the pi. So since it's next to the r, which means it's multiplying it, I'm going to do the opposite, which is divide both sides by pi. And as before, my pi will cancel on the right side, and I'm left with a over pi equals 2 radius squared. Now the question is, what is going to eliminate the power of 2? So if you don't remember this, probably from way before in pre-algebra or another earlier math, what eliminates the power of 2 here is its opposite. So like the opposite of adding is subtracting, opposite of multiplying is division. The opposite of squaring something is square rooting it. So like for example, I'll write it here on the side. If I have 7 squared, it's going to be 49. If I take 49 and I square root it, I get back to 7. So the square root undid what the square did and got me back to my 7 from the start. So that's what I'm going to do to eliminate this power of 2. I'm going to go ahead and square root the left side and the right side. So as long as I do it to both sides, I'm allowed to do it. So the square and the square root eliminate one another, so they kind of cancel each other out. And I'm left with just the radius on the left side, on the right side. On the left side, all of that stuff just stays the same way. You don't do anything to it. Just rewrite that ginormous square root over pi. Everything's on the inside, and then we'll just rewrite it, but backwards. If you want to skip that previous step and write it backwards from the start, that is perfectly fine. So the radius is the square root of the area divided by pi. All right, that's it. Go ahead and do the practice problems and finish up your work.